All right. Welcome, everyone. I'm joined by Chris Anthony. You guys all know him, co-CEO of Aptera. Thanks for taking the time to meet with us, Chris.
Thanks for having me, sir. Your channel's been doing great, and I've been enjoying the videos. We do watch them around here, and we do get feedback from them, so it's great.
Okay, great. Yeah, because I think I put up some polls that I'm hoping are like helpful for you guys for some market research. Obviously the poll for the DC fast charging was pretty conclusive, and you guys quickly addressed that.
We try to keep track of all the content out there, and our marketing and communications team does a good job out of that. But it's a dizzying array of each of Aptera now. Discord channels and chat rooms and videos. It's a lot.
Yeah, it's a lot. You have a lot of rabid fans, me being one of them. So
that's awesome.
That's a good thing, I think.
Yep.
All right, so I wanted to start off with a bunch of kind of like rapid fire kind of yes, no questions, and then we'll kind of get into some other stuff. So first of all, these are questions about the launch edition.
Yep.
Is there going to be a 110 outlet?
Yes, there will be a 110 adapter.
Okay.
Or they actually sell the NACS Tesla plug. That's one end is the Tesla plug and the other end is an extension cord plug. But I've found with my Tesla that it's easiest just to get the little 110 adapter, and you plug it in the NACS port and plug in an extension cord into that NACS port.
Yeah, so I mean, this is to get juice out of the Aptera, like to plug things in.
Oh, you mean like an inverter?
Correct.
We won't have an inverter standard, but we're looking to have an inverter as an option to be able to pull off of a DC line. We're also trying to figure out a way for V to G to work, but nobody's set a standard yet. So it's really frustrating that we don't have kind of any real standard that's been adopted to just jump on the bandwagon with. We're waiting for somebody to come up with something. I was hoping that a lot of these bigger SUVs with huge battery packs, 200 kilowatt hour battery packs, would incentivize a lot more that V to G connectivity, but it's still languishing, unfortunately.
Yeah, I don't think any of us expected V to G, but we were hoping to have a little plug we could plug in a hot plate, or run your refrigerator in the case of a blackout or something for a while.
Yep,
that kind of thing.
We just talked about a 12-volt plug, and you can plug in probably up to 800 watts, 1200 watts.
Okay, so you think that will be available as an option on the launch edition?
Yes. Yeah.
Okay.
If not something that's easily replaced as an accessory later, so something that you just plug in and inverted power and other stuff.
How about camp mode?
Yes. Okay. Software, relatively easy.
Yeah, that seems like a pretty easy thing to implement.
Yeah.
And then I know that
camp mode, all those things.
Okay, great. People will be very excited about that, especially the people that want to go camping, which I think there's quite a few people that want to do that. I know you guys are thinking about putting vinyl wraps. Have you considered this polyurethane cosmetic paint protective film? I don't know anything about it other than that I've read that it's more durable. Is that something you guys have considered? If not, maybe something to consider.
Yeah, at CES, they had a couple companies showing off polymer coatings, which is usually just a fancy word for a wrap. But the wraps come in a lot of different flavors, and the one that we've tested so far is 3M's 2080 wrap material. It's performed very well with our CPC composites, and you basically don't even have to clean the part after it's out of the mold. You can just apply the wrap, is what we found. So more long-term testing is needed. We have Lynn out in Arizona been testing for over a year now, and we're hoping to kind of see the results of how durable these wraps are on our particular composite material. The great thing is that we've kind of limited the wrap area, because it's only like a band on the side of the vehicle now. Yeah. Including the door panel, but that's less than 30 inches wide. So you can order that wrap material from anybody. Everybody makes rolls that are at least 36 inches wide. So we'll also try to make available to you the cut pattern. So if you want to go to your local shop and get a Picasso print to put on the side of your Aptera, you can do that and just have them cut out the pattern and have somebody apply it. So if you get your Luna launch edition vehicle, you can very easily and cheaply hopefully change the color if you'd like.
Okay, great. Heated seats.
Heated seats, I had a question on this, that if we would have the wiring harness connections for heated seats. I know we have a plan for heated and cooled seats because it's a much more effective way to get heating and cooling to the passenger than blowing air at them. The heated seats seem pretty easy, but I don't think we're going to have like connectors under the seat to do that. I think it'll probably be a kit that you'll have to install, and you'll have to run power from somewhere else in the vehicle. But we will have as an option heated seats, if not at launch, very soon after.
Okay. And then heated yoke as well.
We had no plans and have not considered a heated yoke.
Got it. How about the driver assist? We know that's not going to probably be ready at the time of launch. Is the hardware for driver assist going to be on the launch edition? Like, so if the software becomes available, we can just like load it on a software.
Yeah, we tried very hard to get all the hardware to be compatible with level 2 autonomy. The problem is until you have a master supply agreement with a vendor, sometimes those safety critical components are part of that master supply agreement. So until we like have all of the components under lockdown for a supply agreement, meaning you've given them a date on when you're going to receive them and you sign the final contract, we can't really say for sure that these vehicles will be easy to upgrade with just a software upgrade. But that's the intent. That's what the team has been working for. And, all the components are there. Just the fickleness of, what will the supplier say? Yeah, you can go ahead and use this for ADAS functionality, for autopilot functionality.
Okay, because you're going to need like cameras and stuff, I imagine.
Our current system uses just forward-facing cameras, and it's all built into the system. So imagine a module that you plug up that replaces our rear view screen. So I don't know if you noticed, but in the launch edition vehicle, now that's kind of a separate plastic piece up where the rear view mirror is.
I see.
And that was made that way so we could build new features into that in the future. So think of new downlighting, think of new buttons or mics for telephone calls and autonomous packages. So
I see.
You would build in the autopilot system into that plastic bucket, and that would just replace your existing plastic bucket. So if you ordered autopilot from us, you would just take down that old bucket, plug in the new bucket, and screw it in, and you'd be done.
Okay, all right.
That's the idea. Is that
so if the launch edition doesn't come with it, you could probably, it sounds very modular that you could just like swap it out.
Yeah, exactly. So, you call us up and you say, hey, I want this feature, and you can add it in the future. We hope to have it available by launch, but we have a lot of fish to fry, and we'll spend, another 6 months sorting kind of production battles. And then after kind of everything starts on the production line and everything's kosher, then we can divert engineering resources to say, okay, now let's hop back on the autopilot system. But we've had it functioning. I've driven around with it many times on beta. We've driven around with it, and it's a very cool system. I've been I have a Tesla too, so I'm really surprised in how functional and adept it is at everything you need for autonomous driving. So
very good. You know that many of us have a theory on who you're working with, but I'm sure you're not allowed to say who you're working with on level 2.
Yeah, I mean, we're a San Diego company, and we like to work with local partners, and there's lots of great California companies that are developing cool tech like this. And we're a right to repair company and rather open source in a lot of stuff we do. So we like those kind of efforts.
Okay, very good. Cellular connectivity. Aptera is going to have that, I imagine.
We will. Telematics, certainly in the launch edition vehicles will be standard because we want to know what's going on with these vehicles out there. We haven't come up with a pricing plan or selected a final vendor. Luckily, the 4G standards are pretty easy to get at, and there's lots of carriers that do that. And it hasn't been that hard to find those agreements. But long term, you don't want to be paying too much for the data, and we don't want to have to pass those costs along. So you want something that's $2 a month and not $12 a month.
Yes.
So that will come later down the line. But right now we have a system, uses AT&T, works great.
Okay. All right. And then the launch edition is coming with all-wheel configuration. Is that because that was the most popular configuration? Because we were,
it was the most popular configuration. So, the higher engineering hurdle is for all-wheel drive. It stresses the battery pack more. You have one more inverter to control. You're doing stability control with 3 inverters now, so things get more complex. So it's a heavier engineering lift. But it's easier to backtrack to the two-wheel drive after you do it.
I see.
So the engineers kind of came back and said, we don't want to have to provision for three-wheel drive and do all the work for three-wheel drive, but then not have three-wheel drive. 65% of your orders, 70% of your orders are for all-wheel drive. Let's just ship it with all-wheel drive. And then when we want to offer two-wheel drive, you just take the third wheel away, and it doesn't really change any of the downstream. Like everything works for three-wheel drive. It's just whether we include it or not. So that was kind of the driving factor for adding the third wheel drive. And we think, the higher performance in the beginning, it'll be a more spirited drive. It'll have better stability control. We think there's a lot of reasons. The downside is it will not be as efficient. So you're carrying more weight around, and that, in essence is less efficient. You're adding another loss component. You got to push that power through more wires to get to that motor and that stuff. So, it is more total loss when you add the third wheel, and you have more weight. So it's kind of a double whammy on efficiency.
Do you know, is there a way to shut off the third wheel and make it front wheel drive only? And does that give you back any efficiency, or really it doesn't help you in that way?
Yeah, we haven't gotten to the part where we get to do the fun algorithm stuff, which is, when you're driving at a highway speed, are you just driving with the passenger side front motor and everything else is shut off? It's all about keeping the motor in its most efficient power band. So, if the torque curve on one motor is such that at highway speeds, you're burning 1,800 watts, 2,500 watts of power, and only one motor can operate in the best part of its power curve to do that, then that's what we'll do. But maybe it takes two motors that kind of operate in the best power curve at that RPM and given voltage. So there's a lot of factors at play, but once we start doing that testing, that's absolutely the goal, is to have the drive algorithm use the most optimal motor topology and send power where it needs to be the most efficient. But I don't have any real answers for that because we've only done a very little bit of that. They have done some with four-wheel drive vehicles. Lafe has, but we don't feel it really crosses over because those vehicles are so heavy. Our vehicle's just a very unique platform being so light. So we basically have to start from scratch and figure it out again. So.
Okay. All right. Now, I know that in the meeting this morning, I was able to catch some of that. It sounds like there's not going to be side airbags.
Yes, we, the way our vehicle's designed, and the way we've added kind of side, safety in a big boxed out section by your H point in the door seal, and kind of doubled up A-pillars where the door meets the A-pillar. We think we have a very good structure. We're kind of like an egg from the outside. So we think we're very good for side impact, and have chosen to just go with frontal airbags because of that.
Now, I think obviously the carbon fiber frame is very strong, and because of the shape of it, it's very strong because it's basically a bunch of arches. But the airbags, protect the head from hitting the inside of the egg, evidently. And so, when you guys have run some simulations, I know, on the strength of it. Does that simulation include does it simulate a person being inside of there and what the person does?
Yeah, it does. Absolutely. That's the whole goal, is to keep the passenger safe. And the mass of that passenger is a huge part of the equation of how their body moves in an accident. Obviously, in most traditional vehicles, the door is right here, right?
Yeah.
Our door is kind of curved with you. So, kind of side.
So the head doesn't hit the side of the vehicle.
Well, we have a good cone around the head. We have, now with the Gamma design improvements and what ended up in the Delta design, we just have a lot more movement and a lot more space for the mannequin, is what you call it in simulation, to move. And we've done the side impact simulation, both static and dynamic, and it's done really well. So we've gone with the frontal airbags, and we think it will perform very, very well. But we'll share those test data when we there with the public, because we want the public to know, how the vehicle performs. And, we have simulated it and feel it's going to perform very, very well. In our previous iterations, our body structure had the highest roof crush strength of any passenger car on the road. So we think we're doing amazing things with this composite carbon fiber structure that's even better than what we did in the past. So we're going to have really good results, but you got to get there, you got to test it, and then we'll make those available and let people see the videos, and that proof is in the pudding type stuff.
Yep. Okay, great. Now I know that Gamma is still in Europe. Have you guys had a chance to do any kind of like efficiency testing? Obviously Gamma is gonna be different than the launch edition, but have you done any like efficiency testing to know that you're in the ballpark of because of the efficiency that you thought you were going to get out of the thing?
We didn't really do any with Gamma because we get a lot of really good data out of beta, data out of beta. So because we've been able to do really good testing with that, we know where our losses are. We know what our aerodynamic losses are. We know what our rolling resistance is. All that stuff is pretty easy to calculate. So Gamma, was so used before we, got it that we really didn't even try to do any testing like that with Gamma. But it really is, the information that we got from doing a lot of testing on beta, coupled with the improvements that we've made on the design side, improvements to the wheel bearings, improvements to the brake system, improvements to the windings of the motor, some aerodynamic improvements, some weight improvements, shifting weight around. All those things kind of go into our computer model, which shows us, watt hours per mile. That's how we come up with, hey, we're going to reach our targets, and this is how big a battery pack we need to, get the kind of range that we want. But once we get to production, the first pre-production vehicles, one goes to the EPA and they do their own test and they come out with their number and they're like, this is how many watt hours per mile Aptera is, and that's what people kind of live by after that. So I think we'll be particularly interesting to the hypermiler. And the EPA run will be demolished by some of these hypermilers that do all kinds of crazy stuff to their Aptera. They've taken the passenger seat out and all the carpets, they've taped up all the seams, they've done all kinds of crazy, pumped up the tires to 60 psi. That type of fun stuff to hypermile the Aptera will be pretty cool to see.
Yeah, I don't know if you saw, I did an interview with a guy that like totally tricked out his Civic CX and got like 80 miles per gallon out of it. And he was like, he's very interested in the Aptera as well. And he's a reservation holder. And he's like, oh yeah, I already have ideas of things I'm going to do with the Aptera when I get it.
So all those guys working on regular cars, make them more aerodynamic. It's all about underbody and how the body of the vehicle plays with the dirty air from the wheels. So
I mean, a lot of what he did is what you guys already did with the Aptera, like narrowing down the tail and, making the bottom really smooth and things like that. That's the stuff he did. And so, he's a big fan of Aptera too.
Okay.
I was thinking that, I know you guys did a lot of testing with beta, but beta is not aerodynamic at all.
Yes.
So, because, it doesn't have a windshield, doesn't really have a front. You guys, but you feel like just from driving it, just from like seat of the pants kind of field, that Gamma is about as efficient as you expected it to be.
Yeah, what you get is the rolling resistance numbers, and that's the aerodynamics is logarithmic. As you get faster and faster, it gets to be a bigger and bigger loss. That's why the super speedy cars have such a trouble breaking 250 miles an hour, right? It's not really that the motor, can't spin up that high or the wheels can't go that fast. It's that for a given power to overcome the aerodynamic drag at such high speeds is just enormous. So even if you have a 1200 horsepower motor, if you're trucking along at 270 miles an hour, the aerodynamic resistance against you, the motor just can't produce enough power to overcome the aerodynamic. So you see, all these vehicles trying to be more and more aerodynamic to pass those kind of supercar speed records, while keeping the thing on the ground, which is why they apply a lot of downforce. It's
okay. Yeah, absolutely. All right. So let's talk a little bit about the DC fast charging. We've been through a lot of 180s with the DC fast charging. In the launch edition webinar, you guys mentioned, or at least Steve mentioned, that there was some cooling issues to deal with and some like battery pack issues to deal with. I mean, are those not issues? Because then that wasn't mentioned when you guys said that the DC fast charging is back.
When we looked back at DC fast charge, really, I think what was in our mind was, how do you do 100 kilowatts? When we first started trying to package that CCS plug, it was like, oh, this is just a nightmare. Why don't we just hold this until later? We already get almost 60 miles an hour from, level 2 charging. So why don't we just stay in that regime? that seemed like the path of least resistance. Kind of since we made that decision 6 months ago, we had the NACS plug become available because of the awesome campaign that we did, and 42,000 people signing up to hopefully make the NACS a nationwide standard. And we said, hey, we get to use this Tesla plug now, but we never kind of went back and said, okay, we have this new plug that takes care of the issue of the CCS plug being difficult to package. How do we do DC fast charge now? So, we went back to the engineering team and said, yeah, DC fast charge, this is a thing that people want. How do we do it? What are the restrictions? What happened? Why do we really move away? And they said, well, we designed the whole system to easily do 40 kilowatts, but doing a lot more than that was, a lot more work. If you get up to 100 kilowatts, now you have some interesting cooling issues for our 40 kilowatt hour battery pack to take that much power. So, the difficulty in DC fast charge for a lot of these bigger vehicles that are on the market now is you're trying to push so much power into the batteries. The batteries have a natural resistance, and that resistance means that some of the power you're putting into the battery turns into heat. So you don't want to melt your batteries because you're charging them too fast. So you got to actively cool them. So when you're in a Tesla and you're about to go supercharge, you push a little thing on your screen that says, I'm going to supercharger. It says, okay, now, I'm readying the battery pack to be supercharged, and take that energy, but not get too hot from that energy to burn up. So, I think 40 to 60 kilowatts, not a huge challenge after we talk to the engineers. 100 kilowatts, some more significant challenges in DC fast charge. So we feel comfortable now that 40 kilowatts is easy, and with our testing and validation, maybe it's 60, and then 600 miles an hour I think is a really good charge rate that gives people the ability to go do road trips and stop for 20 minutes, a half an hour at their favorite rest stop, and now they have 300 miles in their Aptera, and shoot, you're back on the road and ready to go. Yeah.
So when you guys said that about the thermal issues and the battery issues, you guys were thinking 100 kilowatt hour charging, not 50 kilowatt hour charging.
Yeah, I mean, that's kind of how it evolved.
Yeah.
I think when we said that on the webinar, I was really thinking of, DC fast charge of 150 kilowatts.
Yeah.
There's some challenges there, but the Chevy Bolt, it runs around with 50 kilowatts, and people are really happy with that vehicle, but it uses 3 times the energy that we use. So, we charge 3 times faster on that 50 kilowatt line.
Oh yeah. So like 40 kilowatts or 50 kilowatts on the Aptera is like equivalent to like 150 or 200 kilowatts on another vehicle. Yeah, essentially.
Yeah, it's amazing to see some of these bigger, SUVs and trucks. So much energy per mile.
It's crazy.
Charge that battery pack, they're talking 300 kilowatt DC fast chargers now. Holy cripes, that's a lot of energy.
Ridiculous.
Somewhere.
Yeah. So at the launch edition, will it be able to use a supercharger if Tesla gives us permission to use a supercharger?
Yes.
Okay. Yes. And okay, so the next question is if Tesla does not give us permission to use a supercharger, can you use the NACS port CCS adapter and use it with a CCS fast charger, DC fast charger?
Yes.
Okay, perfect. That's awesome. All right, so last part of this, I wanted to talk a little bit about funding. Do you guys have the funds now to build a physical launch edition for testing, like small?
We do, but we don't want to. What we want to do, and what we'll talk about tomorrow in our webinar on the investor side, is we want to push towards production. And we want to make production tools. We have amazing design partners and engineering partners who have done this a lot, and they all agree that there's no more intermediate step from where we're at now. The vehicle is designed, the production plan is ready. We want to start building production tools, and in fact, some very large and expensive tools are already being cut for production. So, every dollar that we have now, we want to go into the production tools and then validate our vehicle with pre-production vehicles out of production tools.
But you can't, so you're not going to get to those unless you get the funding.
Yes, okay. But we're fully confident that we will get the funding. It's just a matter of time. We have 40,000 orders, $1.5 billion of backlog. This thing happens, but we want it to happen quicker, and there's a lot of reasons why it's not happening as quick as we want, but we're introducing a plan tomorrow to try to accelerate things.
Right. The capital markets are tough these days. I mean, you've seen what's happened to Sono, and Lightyear's having some issues as well, and Archimoto doesn't look like they're doing so great. So I know you guys are in a tough environment. And of course, we all think that Aptera is special and is going to do better than those guys.
We have the opportunity to be the first production solar electric vehicle.
Yes, it looked like Lightyear was gonna, be the first, but they've kind of suspended operations on at least the Lightyear Zero. So
yeah, I mean, we're birds of a feather, and we love those guys, and we wish them well. We want all these projects to be successful. There's no limiting function to the size that this market could be.
Yeah,
Stellar charging for transportation is the perfect solution, we think, for the efficient vehicle market. There's bigger vehicles that if you got to tow a boat or you're doing construction or something, solar electric vehicles maybe don't make a lot of sense, but there's limitless size for where we're at now. And I think we see from the amazing support that we've gotten from 40,000 reservation holders that, we feel that we could build huge numbers of these vehicles, and all these guys, Lightyear and Archimoto and the Scion, they all have a place in this market. Right size transportation, and if you're building something efficient, make it solar powered. We love it. We want those guys to succeed. If we could help them in any way we could, I've tried.
Yeah.
We talked to those guys, so we're
yeah, no, it's a little sad to hear the problems that they're having, and we're all pulling for them too, obviously. So I know you guys applied for the ATVM loan. Is there like a time frame of when you hear a yes or no about that?
We have not applied to any government loan programs yet, but we will.
Okay. All right. Got it. And then, so the number that's often been quoted is $50 million to make it to production. Does that include the $23 million California grant, or is that in addition to the California?
That's in addition to the grant that we've been selected for. We have a lot of kind of ways to fund this program moving forward: government grants, government loans, financing of equipment, and large institutional and sovereign investors coming in alongside the amazing amount of crowdfunding that we've had, which we think we can still leverage to a great degree to get into production. Our number one asset has been our community, and how much they've supported us from the start. And we think that we've got a big enough community now that we can do amazing things, even if some of these other things don't fall in place as quickly as we'd like them to.
Okay. Have any large investors like sovereign funds or institutional investors expressed real interest in the Aptera? Do you feel like that's going to happen?
Yeah, we've had some amazing conversation towards the end of last year, and they're starting to pick up steam now.
Okay.
I think, with the time before the middle year, summer and end of summer, was a pretty difficult time to talk to people.
Okay.
But it seemed to have gotten a lot better towards the end of the year. And now we're having some really positive conversations, and things are starting to move forward. So.
Okay. That's very heartening for us to hear. So for you guys, I know this is probably not a happy thing to talk about, but is there a deadline that you see that if we haven't gotten funding by this time, we're gonna have to sell off our IP or close down shop or something like that? Is it obviously you can't go on for 10 years,
We've done a great job at controlling our spend, and I think we've made amazing progress with the amount of money we've spent so far, compared to any other vehicle program of this type, or automotive program, or even, specialty vehicle in construction or agriculture. I mean, we've done some amazing things with the, $70-ish million that we've spent here. It's a design that's ready for production, but also the manufacturing, capabilities, designing the manufacturing floor, speccing the equipment, doing the cycle time and takt time analysis to see how people move in different operations and what tools they need. All of that stuff has been accomplished now, and we're just waiting to kind of take the next step into production. So I think we don't really have a ticking clock that we're facing now, but until we start writing the big checks for tooling and equipment, we don't kind of step into this 12-month plan to get to production. production. It takes kind of 6 months to start receiving a lot of the bulk equipment that we need, and 9 months to start commissioning it and start things running. And then you've got to do kind of line validation and all that stuff. So Pablo and his team is saying, if we're able to have a great webinar tomorrow and start to kick off things in January, February, then it's about a year from there to really start seeing volume production and delivering people's Apteras to them. So that's we're up against is we can continue, but until we start writing the big checks for tooling and equipment, we're not stepping into that 12-month plan. We're accomplishing some great things, as a company, progressing solar, doing limited production, software and firmware teams, and the mechanical engineers working with vendors to refine things along the way, and that will really help the end product design. Thinking about validation plans and doing all that kind of pre-production planning is great stuff that we can do now. We've got an amazingly talented team to do it, but we want to start stepping into production.
Yeah, absolutely.
No doubt about it.
Yeah. Absolutely. I mean, we all want production to have happened, yesterday, but
we would have loved to have closed a big round, towards the end of last year, and just been able to start off the new year, with all the things in place to have production ripping and rolling by the end of 2023. But it really does seem like it's a 12-month plan from when we get the right financial mechanisms in place to start to execute. So we'll have a webinar tomorrow. We'll talk exactly about that and how people can help us step into that 12-month plan.
So I was at that the preview webinar this morning, and I was very impressed with all the things that you guys have been able to accomplish. Like you said, with $70 million, which sounds like a lot of money, but we know like Lucid and Rivian took like 2-3 billion before they made it to production. So the engineering that you guys have been able to do is, frankly, seems really amazing what you guys have been able to accomplish. So I'm sure you and the whole team is very proud of that.
Yeah, it's been an amazing effort, and we've been developing really new and unique technologies all along the way, from the aerodynamic suspension to the monocoque chassis out of carbon fiber SMC to solar that was designed from scratch by Anuj and his team, a battery pack that's the most energy dense in the industry. I think a lot of kind of big firsts and new technology have been created on a very limited budget. To be honest. Okay, I know our time's almost up, but I want to ask you one more question about the UI. I know that's kind of been on the back burner as you guys kind of lock down more of the physical components, because the UI is the stuff that you can work on now. Do you know if the UI is going to be like open source? Are people going to be able to modify it? Or is that kind of stuff that's a good question. I know the safety layer kind of exists outside of the UI. So even if the UI glitches or isn't available or crashes, it doesn't affect your vehicle performance, and you can still drive and put it into gear and all those things. So I don't know that we would be opposed to people, modifying it to their needs. But I imagine that in general, we would want to keep it fairly locked down, so we have something that's reliable and trustworthy. Though we do, I know a lot of people are really secretive about their CAN messages. I don't think we're going to be that way. You want our DBC file to figure out what our CAN messages are saying, because you want to put something X in the vehicle, Sure. You want to see the battery data in a different way than we're publishing, and you want to just link to the CAN and see that info. Sure, great. We want people to know how their Aptera is performing, and how it's lasting over time. So we want to give them lots of information about how their battery pack and drivetrain and solar package is performing, so they can get the most out of it.
All right. Well, thank you very much for your time, Chris. I look forward to the time when I can come down and visit you guys and look at the launch edition.
It's awesome. You're doing amazing work with your channel. Keep putting out great information about Aptera and the EV industry as a whole, and the world as it is impacted by solar mobility. But it's just amazing that you and your fans have such a spirited discussion about what we're doing. And we're trying to make it happen for you and all the other fans we have out there, because we think that solar mobility makes the world a better place, and efficient transportation, really has a place in this world. And we're going to make it happen.
All right. Thanks, and good luck, Chris.
Awesome. Thanks, Steve.
Bye.